Hello and welcome to the webinar to introduce the ULINKplus. My name is Peter Barnard, I work as an applications engineer for Element 14, and I'm here with Christopher Seibel from ARM, who is going to explain the unit to us and do a demonstration. Christopher, are there a lot of debug adapters on the market at the moment? What makes the ULINK special?
Well, that's an excellent question, Peter. Thanks. ULINKplus offers, of course, debugging capabilities, but also offers power measurement and I/O pins for test automation, and all in such a small box.
Oh, I thought that is actually very small. That's
yes.
About, smaller than a credit card size.
It is.
Yeah. That's,
And actually, if you think about it, like 3D modeling gives better views into a mechanical design, we believe that synchronized views to events, to timing, and of course to power consumption gives much more insight into your embedded design. So we say that just like an oscilloscope for the electrical engineer, every software developer should have one of these units on his desk.
That sounds really amazing. Quite a cool unit. So this actually feels quite a hefty unit in a way. It's very solid. Is that normal? Is that plastic?
It is actually plastic. We initially started with a standard off-the-shelf ABS plastic, but we were not satisfied with the thermal results of it. And this plastic is enhanced so that it actually acts almost like aluminum. So you could, for example, put that into any metal rack. You would have had the isolation from because it's plastic, but you have a perfect thermal conductiveness.
That sounds very well thought out. Excellent device. I noticed that you've labelled it up really well with pinouts as well on the back.
Yes, so actually this is what we call our super small user guide. You know exactly what to connect where, and you don't need any documentation just to get started quickly.
Oh, excellent. Yeah, so if power, JTAG, IOs and USB.
Yeah. And for example, especially this unit has another great feature. The JTAG connection and the power pins are isolated, so you can do sensitive measurements, and especially they are even isolated from each other, so you can measure whatever you like with the power pins without any correlation to the JTAG ground, for example.
Right, that's really brilliant. And that's all built in, your isolation.
That's
no external adapters needed.
All built in.
All in that little unit.
Yes, exactly.
Right.
Perfect.
Excellent. So, Christopher, the ability to measure power, isn't that really only useful for ultra-low power battery applications?
That's a good question, but before answering it, please let me have a short demo of the unit. I have here a development board from us, the MCB STM32F400 board, with an F4 device from ST Microelectronics, and I just wanted to show you quickly how this works and what you can see.
Yeah, no, I'd love to see.
Okay,
yeah.
I come back to the question later.
Right, okay.
Yeah.
In this demo, you can see the activity of an RTOS kernel and various peripherals. Let's run the application for a while. Stop here. The power measurement data is recorded in the new System Analyzer window.
What are the higher spikes?
These are spikes that originate from the RTOS thread activity. Let's zoom right into the current graph. Now I can use filters to get different representations of the graph. Let me start with a high filter frequency. This helps to see details on large spikes. You can actually see how capacitors are discharged. Let me use another zoom level. Here. To get more out of small changes, I use the 5 kHz filter. I enlarge the spikes with the min-max auto feature again. Suddenly, you see small spikes here. I use the marker and the cursor to calculate the time difference between two spikes. Down here I see it's 33 milliseconds. If I check the user manual of the board, I see that we have an integrated camera that has 30 Hz samples. So this must be it. Luckily, I can disable the camera interface using a jumper. Let me do that quickly. I run the program again. The spikes are gone. Finding things like that is very hard with an oscilloscope. I have here two example captures. The first one is a HAMEG low-cost oscilloscope. You can see that the SV call and the cystic spikes are clearly visible, but the real problem is hidden in the noise. The second one is a $10,000 Textronics oscilloscope. It's a bit better, but still it does not give you the insight that you gain with System Analyzer.
You can see much more than in the oscilloscope.
Another thing that you can see here is this small current change. This comes from an I/O pin that has a pull-up resistor configured. In my actual application, I would not need it, so I can remove this configuration to save power.
This does not require an internal pull-up. Amazing. You can work down to the pin level.
Pin or peripheral level, yes. In a similar way, you can actually see the power consumption of peripherals such as an A to D converter or CAN controller. You can therefore identify if you have accidentally powered peripherals that you don't need.
See, this lets me analyse your power supply. I guess this is relevant for devices with high precision analog features.
Yes, it is. And by the way, we are using two high precision 16-bit sigma delta A to D converters with 20 MHz sample rate for a high signal to noise ratio. By default, the current range is 2.5 mA with the internal built-in 100 ohm shunt resistor. It can show current changes down to 200 nanoamps. In this example, I'm using an external shunt that extends the measurement range to 100 milliamps maximum. We are shipping 6 shunt boards with the probe.
That's really good. Can you show me the test AO in action?
Sure. Here I have another project where I have connected 2 I/O pins to the development board. I'm using one of them to execute the wait for event instruction in the idle thread of the RTOS. Here we see how much current is drawn. That's quite a lot. But as soon as I press this button, which I have connected to the I/O pin using a debug script, the current consumption goes down as I enter this low power state during idle. I use the other I/O connected to the development board to check the digital level of one of the LEDs. You can see the I/O toggling in the ULINKplus window.
This is really interesting. Can you explain to me all the features of the pins?
ULINKplus has 9 I/O pins that can be used either as digital inputs or outputs. 4 of them can be used as an analog input, and we also have 1 analog output. You can configure this using the ULINKplus window, or using our integrated scripting engine. Our template script file helps you getting this set up for your debug session. It also contains some example signal functions that can be used with the analog or digital outputs.
It's a brilliant unit. It can do all this.
Thanks. Together with our command line interface, you can run continuous integration tests on real hardware. You can interact with the target under test or control automated test stands. This helps you to do nightly builds of your software and test it fully autonomous using build servers.
In my everyday work, I really like the new event recorder that provides event timing and data information while the program is executing. It really improves my debug experience and helps me find bugs faster, especially in libraries that are beyond my control. Are features like event recorder and component viewer also supported with ULINKplus?
Both features only rely on memory reads and writes, which means that they are fully independent from the debug probe that is used. So yes, they are available with ULINKplus as well, only that they are really fast. I enable both features in this application. Here it is. The component viewer gives us the information about the threads that are running, while the event recorder shows all calls to the API. Together with the new System Analyzer, you get a really good overview of the operation of your application.
You show me a little bit more of that.
Sure. The System Analyzer also shows you the clock that your target is running on. Modern microcontrollers are feature-rich and offer very flexible clock configuration. While this is an advantage for the embedded engineer, setting up the clock correctly can also be painful and error-prone. This feature clearly shows if you have configured it correctly.
That's really good.
System Analyzer can do more. Using the tracing capabilities of ULINKplus, it shows you exceptions and interrupts, such as the SV calls and the sysdig timer. Finally, we have added the Logic Analyzer capability to it, so that you can track value changes of variables or VT-regs in a graphical window. I have done this here with a timer variable that I'm using in one of the threads.
That's a great feature.
Thanks! We really want to give users the complete overview of their design in one window.
Right, so there's a lot of debug adapters out there, quite low cost on the market. Some seem to have more features, some worse. But in general, I think I'll be correct in saying that most of them seem to be quite slow. How does a ULINKplus compare?
The ULINKplus is actually very fast. For capturing trace information, it can run up to 50 megabit per second serial wire output trace in UART mode. And for your event recorder annotations, it can read and write memory up to 1 megabyte per second. So it's the perfect match for your application.
Oh, that's really amazing. That's really good. Well, that sounds absolutely amazing. Question is, are these actually available now? When can I get one of these from Element 14?
We have started to stock all our distributors. Element 14 is one of them, so people can start ordering right now and we'll get the unit before Christmas.
Oh, excellent. Thank you, Christopher.
Thanks a lot.
Oh, and by the way, we have a special offer for ULINKplus during the introduction phase. With every seat of MDK Professional or MDK Plus, you get a free ULINKplus. With this, we hope to get them onto the desks of software developers fast. Thanks for joining the webinar. Now let's take a look at your questions.